नमस्कार बच्चों, मेरा नाम धन्या और हम लोग सीख रहे हैं ग्रेड 11 केमिस्ट्री का फोर्थ लेसन जिसका नाम है केमिकल बॉन्डिंग एंड मॉलिक्यूलर स्ट्रक्चर। द प्रीवियस वीडियो यू लर्नड अबाउट द सिग्मा bonds and pi bonds, okay, and the difference between them, how they are formed, okay. And in today's video we will be learning about a special type of bonding which is called p-pi bonding and p-pi bonding. This part is very important for JEE and NEET. Okay. In the school exam, they don't ask much about this, but for a competitive exam, they ask questions from this area. Okay. So in the previous video, we learned about sigma bond and pi bond. Okay, just to revise, sigma bond is formed by the axial overlap of the orbitals. It is formed between SS orbital, SP, and also PP, head-on overlap. Okay, it is formed by the head-on overlap of either SS, SP, or PP orbitals. Okay, and pi bonds are formed by the lateral or parallel overlap of PP orbitals between PD or between D and D. Okay. So if I have two atoms, if I have a single bond, definitely it is sigma bond. If I have a double bond between them, one is a sigma bond which is formed first and then pi bond is formed. And in the previous video, we also saw examples of double bond, oxygen. We also saw triple bond, molecule having a triple bond. If it's a triple bond, the first bond is a sigma bond. The next two bonds are pi bonds, right? And we saw some examples of sigma bond formation and pi bond formation. Okay, so these are the things last video we learned. In today's video, we will be learning about the special type of bonding, as I said, these p-pi, and p-pi bonding, which is very important for competitive exam. Okay, so let's get started with p-pi, d-pi bonding. Okay, and here we already learned that pi bonding is formed how? Pi bonding is formed by the sidewise overlap, sidewise or lateral or parallel overlap of the orbitals. Right. So in p-pi, d-pi also there will be, because it's pi bond, there will be sidewise overlap of p orbital. So this is the two lobes of p orbital, plus and minus p, plus what is the next orbital mentioned? D. So for D, we have the four lobes of the d orbital. This is the d orbital. So I have plus. So these are the four lobes of d orbital. When they overlap, it results in the formation of so this here I have one electron. Here I have another electron. You know that when there is overlapping of the orbitals must be half filled. So I have one electron in p orbital, one electron in d orbital, and the electrons must be in opposite spin. This was discussed in the last video, right? So when p orbital and d orbital half filled, p and d orbitals overlap, it results in the formation of sorry, I'll draw once again. 。 I'll draw a bit bigger. So this is the electrons I would show over here. 2 electrons, okay? And this is p pi d pi bonding, okay? So when p orbitals overlap with the d orbitals, both of them are half filled with electrons with opposite spin, they overlap to give you p pi d pi bonding, okay? So this is an example. Now, similarly, I have d pi, d pi. In d pi, I have d orbitals are overlapping with the d orbitals. Okay, so I'm drawing the d orbital, which is half filled. I have another d orbital that is also half filled, but the electrons have opposite spin. Okay, that was a rule that was mentioned in the previous video. Now they overlap, so d orbital overlap with d orbital to give so they overlap like this. And the electrons have opposite spin. This is the d pi bonding. Okay, so p pi d pi is formed between p orbitals and the d orbitals. Okay, and d pi is formed between d orbitals and d orbitals. Okay, now there is another type of bonding that we learned last video, that is just to p pi bonding. Just to revise with you, p pi bonding. This was done in the previous video, but just to revise, here the p orbitals overlap with p orbitals, each having electrons with opposite spin to give you p pi bonding. Okay, now this is p pi bonding. So we just now we saw about p pi bonding, p pi d pi bonding, and d pi bonding. Now, if you compare the three of them, you will see the extent of overlap is more in this p pi bonding. Okay, so this was discussed in the previous video. The p pi bonding is the extent of overlap is more. Extent of overlap, all of them are sidewise overlap. So the extent of overlap is more in p pi bonding. So if the extent is more, that means it is more stronger bond. So p pi bonding is more stronger than the rest. P pi d pi and d pi. Okay, so in the previous video we learned that if the extent of overlap is more, it will be a stronger bond. If it's stronger, the bond energy will be more. Bond energy more means bond length will be less, inverse proportion, right? So this was about the strength, comparing the strength of the three bonds. Okay, now the type of questions that come is question 1. How many p pi, p pi, p pi, d pi bonds are in sulfur dioxide. Okay, so this is the question. How many p pi, p pi, p pi, d pi bonds are in sulfur dioxide? Okay, so sulfur, this is the structure of sulfur dioxide. We discussed this in the Lewis dot structure. It has a lone pair of electrons, right? Now, in sulfur dioxide, there are two double bonds, okay? So if there's a double bond, one is a sigma bond, one is a pi bond. Here also, one is a sigma bond, one is a pi bond, right? Now, there are two pi bonds here. Now we need to check if it's a p pi bond, p pi bond, or p pi d pi bond. Okay, so that's what we have to check, and that's what they have asked. How many p pi and p pi d pi bonds are there? So they're talking about the two pi bonds. Now, let's start with writing the configuration of sulfur. Sulfur is 16, so 1s2, 2s2, 2p6, 3s2, 3p4. Okay, so we don't take the inner orbitals, we just take 3s2. This is the 3s, and 1, 2, 3, 4. Now, over here, in the previous video also I had said that bonding takes place only when there are unpaired electrons. Here for sulfur, so this is the 3p orbital. For sulfur, there are only two unpaired electrons. It is forming 4 bonds. For forming 4 bonds, it needs 4 unpaired electrons, right? So this for the forming 4 bonds is not possible over here. Okay, because it has only 2 unpaired electrons. Okay, so from here only 2 orbitals are able to overlap to form 2 bonds. Okay, but we need 4 unpaired electrons for forming what? We need 4 bonds to be formed. We need 4 bonds, 1, 2, 3, and 4. But here available 2 unpaired electrons only. 2 unpaired electrons means 2 bonds, but we need to form 4 bonds. So for that, this is the ground state. In the ground state, the electrons, if energy is provided, it will move on to higher energy state. So what comes into play is the 3d orbital. Okay, so 1, 2, 3, 4, 5. Okay, so students, what would happen is that one electron from 3p will jump to 3d. Okay, and we have the first excited state. This is 3s. 3p, how does it look like now? 1, 2, 3, and the electron, that one electron has moved to 3d. Now, how many unpaired electrons are there? 4 unpaired electrons, right? Now, 4 unpaired electrons are there. So it can form, it is ready to form the 4 bonds. Now, let's talk about oxygen now. Oxygen is 8, 1s2, 2s2, 2p4. Right. So, I will draw the p orbitals only, right? So, similarly, one more oxygen is there, same configuration, 1s2, 2s2, 2p4. There are 2 oxygens, right? So I'll just draw the 2p orbital. So 1, 2, 3, 4. Here also, this is the 2p for oxygen. This is the 2p for oxygen. 1, 2, 3, 4. Okay, so see here, I'm drawing the spin opposite to what I have drawn in for the unpaired electrons of sulfur, because we know that when the orbitals combine, the electrons must be in opposite spin. That's the reason. Okay, now students, if you see, there are 4 unpaired electrons in sulfur. This is for sulfur, and this is oxygen, and this is oxygen. Right. Now, there are 2 sigma bonds. Yes. Now, sigma bonds is formed. 2 sigma bonds are formed. That sigma bond is formed between 3p orbitals of sulfur with 2p orbitals of one of the oxygen. One more sigma bond is formed. So 2 sigma bond we have. And one more sigma bond is formed between 2p orbitals of oxygen with 3p orbitals of sulfur. Right. Now, what we are left with over here is 3p orbital of sulfur and 3d orbital of sulfur. And for oxygen also, we have 2p orbital each. Now, pi bond can be formed between 3p orbital. So I'm talking about pi bond now. So pi bond is formed between 3p orbitals of sulfur with 2p orbitals of oxygen. So 3p orbital of sulfur with 2p orbital of oxygen. This is pi bond, right? So I'll write it here, okay? I'll write it here. So we got the 2 sigma bond. Now we are talking about the 2 pi bonds, okay? So pi bonds are formed between 2p orbitals of oxygen and 3p orbitals of sulfur. This is one pi bond. So this is p pi bond. How many in number? 1 in number. Because the other one, if you see, I have 3d and 2p of oxygen. So the other bond is formed, other pi bond is formed between 2p orbital of oxygen, that is p pi orbital of oxygen with 3d orbital of sulfur, if you see, 3d orbital of sulfur. So this is p pi d pi bond. How many in number? 1. So we do have 2 pi bonds, but both are not p pi bond. One is p pi bond formed between 2p orbital of oxygen with 3p orbital of sulfur. Okay, and the other one is formed between 2p orbital of oxygen with 3d orbital of sulfur. Okay, so it's a p pi d pi bond. Right, so these type of questions are common. So when you practice, you can do it faster. Okay. So students, this is a second question. Similar to the previous one, how many p pi and p pi d pi bonds are formed in sulfur trioxide? Okay, so sulfur trioxide, the structure S double bond O, S double bond O, and S double bond O. Okay, and if it's a double bond, one is a sigma bond, one is a pi bond. Here also one is a sigma bond, one is a pi bond. One is a sigma bond and one is a pi bond. Now there are 3 pi bonds So we have to check whether these pi bonds are p pi or p pi d pi, okay? And we have to tell the number, how many, okay? So let's start with the configuration of sulfur. Sulfur is 1s2, 2s2, 2p6, 3s2, 3p4. So I don't need all of them, the inner orbitals. I just need 3s2, 3p4. So I'll just draw only 3s2 having 2 electrons, 3s2 and 3p. So 1, 2, 3, 4. So this is the p orbital. Now here you can see for sulfur only 2 unpaired electrons are there, right? So 2 unpaired electrons are there. But it has to form how many bonds? It has to form 1, 2, 3, 4, 5, 6 bonds. So it needs 6 unpaired electrons. So it needs 6 unpaired electrons. So what can be done? This is the ground state. So what can be done? The electrons will, so we have to bring in the 3D orbitals into play. So this is the 3D orbital, 1, 2, 3, 4, 5. So this is the ground state. So the electrons can jump from 3p orbital. One of the electron can jump from 3p orbitals to 3d. And from 3s also it can. So this will be the first excited state, okay? So but this is not enough. Here it will have only 1, 2, 3, 4 unpaired electrons. This is not enough. We need 6 unpaired electrons. So one more electron can jump from One more electron can jump from 3s to 3d. This is the second excited state. So I'm drawing the second excited state because 2 electrons have jumped, no? So that's why second excited state. So in the 3s, I have 1 electron now. In 3p, I have 3 unpaired electrons. And 3d, 3, 4, 5, I have 2 unpaired electrons. So has it achieved the valency? Yes. 1, 2, 3, 4, 5, 6. There are 6 unpaired electrons. There are 6 unpaired electrons. Right. Now, so sulfur is now ready. Now let's start with oxygen. Okay, so I'll just write down the configuration. How many oxygen atoms are there? 3 of them are there, right? So 3 oxygen atoms are there. So oxygen, the configuration is 1s2, it is 8, atomic number is 8. 1s2, 2s2, 2p4. So I don't need the inner orbital, so I'll just draw the 2p4. So oxygen, 1, 2, 1, 2, 3, 4. I've drawn the spin opposite to that of sulfur, okay, because for orbitals to combine, the electrons must have opposite spin. This is 1 oxygen. The second oxygen, same way I would draw 1, 2, 3, 4. Spins opposite to that of sulfur. Again, 1, 2, 3, 4. Okay. So I have the sulfur, I have the 3 oxygen. Okay. Now, let's check out the sigma bond. Okay. So sigma bond, there are 3 sigma bonds, right? So sigma bond can be formed with s orbitals of sulfur with p orbital of oxygen, right? Second sigma bond can be formed with p orbitals of sulfur with the p orbitals of oxygen, second oxygen. Yes. The third sigma bond can be formed with p orbital of sulfur with p orbital of third oxygen atom. Right. Now, coming to pi bond. There are 3 pi bonds, right? So the pi bond can be formed between 2p, I'll change the color, 2p orbital of oxygen, 2p pi with 3p orbital of sulfur. This is the pi bond. It can also be formed between 2p orbital of oxygen, 2p pi, with 3d orbital of sulfur. This is another pi orbital, pi bonding. Right. There is yet another bonding, that is 3p orbital of, 2p orbital of 2p orbital of oxygen, 2p pi with what? 3d orbital of sulfur, third pi bond. Right? So these are the 3 pi bonds. So among the 3 pi bonds, p pi bonding, how many are there? 1. And p pi d pi bonding, how many are there? 2. So what is the answer to the question? There are p pi bond is 1 bond. P pi d pi bond, how many are there in sulfur trioxide? 2 of them. Okay, so we got our answer. Right. So this is how we do. So with practice, you can make it faster. Okay, you can do even more faster. Now coming to yet another question, question number 3. Find the number of p pi, and p pi, d pi bonds in H3PO4. Okay, structure and all, don't get worried. With practice and when we learn different lessons, the structure you can automatically get the structures. It will be easy. Now H3PO4. Now phosphorus, so make it bit bigger. Phosphorus is bonded to one of the oxygen with double bond, with 3 other oxygen with single bond, and these oxygens are connected to or bonded to hydrogen. Okay. Now, starting with phosphorus. Phosphorus is 15. Writing down the configuration. 1s2, 2s2, 2p6, 3s2, 3p3. Okay. So I don't need the inner orbital. I need s and p. Okay. So this is 3s. And this is 1, 2, 3. 3p orbital. Okay. Now, over here, let's write the number of bonds, okay, which is sigma and which is pi. Here there's a double bond. One is a sigma and one is a pi bond. Right. And this is a single bond, sigma, sigma. All single bonds will be sigma bonds, right? Sigma, sigma, and sigma. Okay. Now, over here, we need the bonding of phosphorus. Okay, so we will not be talking about the bonding of O and H. Okay, so here we will see how many bonds phosphorus is forming with oxygen, because phosphorus is not connected to hydrogen, right? So phosphorus has how many bonds? See, 1, 2, 3, 4, 5 bonds, right? So it has 5 bonds, but we have 3 unpaired electrons. Only 3 unpaired electrons are there. So it can form only 3 bonds, but we need to get how many? 5 unpaired electrons. So our 3D orbitals will come into play. So 3D will come into play. 1, 2, 3, 4, 5. Okay. Now what would happen? The electrons can move to, the electrons of 3s can move to 3D. Because one electron is shifting, we have the first excited state. First excited state. So what do we get for the first excited state? 3s has 1 electron. 3p, no change. 1, 2, 3. What about 3d? 3d will get 1 unpaired electron. So 1, 2, 3, 4, 5. So 5 unpaired electrons. So it can form 5 bonds. Okay. Let's move on to oxygen now. So how many oxygens are there? 4 oxygens are there, right? So oxygen is 8. So 1s2, 2s2, 2p, 4. So I'll just draw the p orbital. 1, 2, 3, 4. So I'm drawing the spin of electrons of oxygen opposite to that of sulfur. Okay, this is the first oxygen. Second oxygen, same way I will be drawing. 1, 2, 3, 4. Third oxygen, same way I will be drawing. 1, 2, 3, 4. Fourth oxygen, same way. 1, 2, 3, 4. Okay. So now let's check out. Now both oxygen and sulfur are ready now for the orbital overlap. Now I have sigma bond. Okay, sigma bond can be formed between 3s orbital of sulfur with p orbital of one of the oxygen, right? Then again, I have, so 3s is combining with 2p of oxygen to give you sigma bond. Okay, this is for sulfur, this is for oxygen. Okay, so I'm just writing that. Okay, again, I have 3p orbital of sulfur. Sorry, I'll write oxygen first and then oxygen and then sulfur. So 2p and 3s. 2p and 3s to form sigma bond. Okay, first. Okay, sigma bond. Now again, I have 2p orbital of next oxygen with 3p orbital of phosphorus. So 2p, 3p. That is also sigma bond. Okay. How many sigma bonds? 4 are there. We have got only 2 sigma bonds. 2 more to go now. 2p orbitals of oxygen with 3p orbital of phosphorus, giving you sigma bond. Sorry, this is not sulfur, this is phosphorus. Okay. Again, 1, 2, 3 sigma bonds. One more we have 3p orbital of phosphorus with 2p orbital of oxygen. Again, sigma bond, right? Now, how many pi bond is there? Only one pi bond is there. So that pi bond, obviously, the 3d orbitals will participate to form the pi bond. So I have 2p orbitals of oxygen with 3d orbital of phosphorus to form what? Pi bonds. So it is a p pi. So it's a p pi d pi bonding. So there's only one pi bond. What kind of bonding is that? P pi d pi bonding. Now you will be asking that there are 3 electrons left here for oxygen. Those 3 electrons will be used up to bond with hydrogen. So these 3 unpaired electrons of oxygen are used up to form bonds with hydrogen. See, there is oxygen and hydrogen, there's a sigma bond. Oxygen and hydrogen, there's a sigma bond, right? So these 3 unpaired electrons are used up to form those hydrogen bond. But we are concerned here with the pi bond that is formed between phosphorus and oxygen. So how many are there? Only one pi bond is formed between phosphorus and oxygen. And what kind of bond it is? P pi d pi bond. Okay, so it is p pi d pi bond and p pi, sorry. What about p pi bond? It's not there, it is 0. So only one p pi d pi bonding is there in H3PO4. Okay. Now, similarly, I hope you got a lot of practice now. You will be able to do it all by yourself now. Okay. Anyway, let's practice one more question. You need to find, the question is the same. Find the number of p pi, and p pi d pi bonds in H2SO4, sulfuric acid. Okay. So the rule is the same. First, we draw the the structure of sulfuric acid. Okay. Double bond, OH, OH. We write the configuration of sulfur, that is 16, 1s2, 2s2, 2p6, 3s2, 3p4. Drawing we don't need the inner orbitals, we need only from 3s. This is 3p, 1, 2, 3, 4. Okay. Now here, as you can see, let's write the bonding. What kind of bond is there? Here there's a double bond. So one is a sigma bond, one is a pi bond. Here also double bond, sigma bond and pi bond. Here single bond, so sigma. Here also sigma. Now if you see, sulfur is forming how many bonds? 1, 2, 3, 4, 5, 6 bonds. So it needs 6 unpaired electrons. But here you can see only 2 unpaired electrons are there. So this is the ground state. So we need to make make room for the unpaired electrons. Okay, so what comes into play? The 3d orbitals come into play. 3d orbitals come into play. So how many unpaired electrons we need? 6 of them, right? So what can be done? One electron from this 3p jumps to 3d, but that's not enough. There should be one more electron moving from 3s through to 3d to get 6 unpaired electrons, because sulfur needs to form 6 bonds with the oxygen atom, right? So because 2 electrons have moved, so it is second excited state. So this is 3s, 1 electron. This is 3p, 1, 2, 3. This is 3D. 1, 2, 3, 4, 5. 1, 2. Okay, second excited because 2 electrons have moved. If 1 electron has moved, one first excited state. Second electron moving, it is second excited state. So sulfur is now ready. Now, oxygen. How many oxygens are there? 4 oxygen. Okay. So oxygen, it is 8. So 1s2, 2s2, 2p4. Okay, so I'll be drawing only the 2p orbital, 2p. 1, 2, 3, 4. Okay, the electron spin is opposite to that of the sulfur. That's why I'm drawing the spin in this way. Okay, this is the first oxygen. Second oxygen also same way. 2p. 1, 2, 3, 4. Third oxygen. 1, 2, 3, 4. Fourth oxygen. 1, 2, 3, 4. Okay, so oxygen is now ready. Now, I'll draw the sulfur, the structure over here so that sulfur, double bond, OH, OH, sigma pi, sigma pi, sigma, sigma. Okay, so there are 2 sigma bonds here. Okay, so I'm talking about the bond between sulfur and oxygen. Okay, so over here I have oxygen, sulfur. Okay, so a sigma bond can be formed between the 2p orbital of oxygen with 2p orbital of oxygen with 3s orbital of sulfur. That's a sigma bond. Yes, there's another sigma bond. You can see 2 sigma bonds are there between sulfur and oxygen. Right. Now, there's another sigma bond that can be formed between 2p orbital of oxygen with 3p orbital of sulfur. That's also a sigma bond. Right. Now, the third sigma bond, there is a third sigma bond and the fourth sigma bond, right? The third sigma bond can be formed between, so all the sigma bonds I'm doing with the blue color, okay? Sigma bond can be formed between 2p orbital of oxygen with 3p orbital of sulfur, third sigma bond. There is a fourth sigma bond that can be formed between 2p orbital of oxygen with 3p orbital of sulfur, right? So between sulfur and oxygen, the sigma bonds are over, okay? Now I have 2 pi bonds. The pi bonds can be formed between 2p orbital of, I'll use a green color, 2p orbital of oxygen with 3d orbital of, so it's a p pi, d pi bond, right? We have one more pi bond being formed. Okay, so this is one pi bond, this is another pi bond. So another pi bond is formed between 2p orbital of oxygen with 3d orbital of sulfur. So it's also p pi d pi bond. So how many p pi d pi bonds are formed? There are 2 bonds, 2 pi bonds. So 2 pi bonds. So 2 pi bonds, which are the 2 pi bonds? P pi d pi. Both of them are p pi d pi bond. Okay, here, yet you can see there are 2 unpaired electrons left for oxygen. That is nothing but the bond between oxygen and hydrogen, These unpaired electrons are formed, used to form the sigma bonds between oxygen and hydrogen. But here we are talking about the pi bond between sulfur and oxygen. So that's why we are not talking about oxygen and hydrogen, the bond between oxygen and hydrogen over here. Okay, so students, how the two pi bonds, what kind of pi bond is there? P pi, D pi bond. How many in number? 2 in number. So it is 2 in number. P pi, D pi bond, 2 in number. Okay, so students, in today's video, we talked about the pi bond. We did some questions on P pi, and P pi, D pi bonds, which is very important for the JEE and NEET. A lot of questions are asked from this part. Okay, our next video will be on hybridization. Okay, so students, that's all for today. Thank you. Have a great day.